Ever wanted to build your very own AI push-up counter? Guess what? You are at the right place. In this very tutorial, I'm going to take you through from scratch how you can build your own AI push-up counter. And the fun part of it all is that you get access to this code and you can play with it. So if you are glad about this, follow me through this tutorial and I promise you are going to definitely learn something new. Alrighty guys, and welcome back. So before we get started, if you are new here, consider subscribing so that I don't miss any of my future tutorials. So the first thing I would like you to do is just to click the search bar on your taskbar and type CMD. You click enter and I'll maximize mine here so that you can see. So what we are going to do is restore the libraries that we'll be using for this particular tutorial. And the first library I would like you to install is opencv. So you just write pip and you type install and type in opencv-python. You have to hit enter and it will go ahead and download for you, but you need an active internet connection to be able to download this library. The next library is numpy, so you do the same, pip install numpy. You click enter and you can see my requirements are already satisfied because beforehand I've went ahead and installed this. We also install CVZone, so you do the same thing, pip install. You hit enter and it will also install successfully. So with the libraries being installed, we just have to close this up, create a new Python file, and we'll call this file pushup.py. So you just have to type pushup and you click enter. So the .py extension will be added automatically because I'm using PyCharm, which auto completes this. Okay, before we import these libraries, let's go through the MediaPipe landmark file we'll be using. So it's here, and we are going to do our project based on the body landmarks. So this is what MediaPipe gives us: all the points on the human body and their corresponding number. So ours is to extract the point 12, 14, and 16. They will find the angle at point 14, and based on this angle, we are going to justify whether or not the person is performing a push-up. The same thing applies to the other hand, which is the left hand in this case. 11, 13, and 15 are the points we are going to extract, and based on this point, we'll find the angle at 13 and also decide whether or not the person is performing a push-up. So we'll be visiting or referencing this image as we go, so keep that in mind. And now let's go right into importing our libraries. I can close this up by double clicking, and I'll maximize this a little bit and we'll import the library. So I'll go ahead and import all the libraries we need here. Okay guys, so I've imported all the libraries and I'll go through one by one with you guys. The first library we've imported here is the opencv library, which we are going to use to handle the computer vision part. We've also imported the numpy library for performing some calculations. We imported CVZone, and also we are importing the pose module from CVZone. So CVZone will help us as wrapper for the pose detector module. And finally, before I even forget, let me import the math module. So we'll import math because we'll use it to find some angles. Okay, so these are the libraries we've imported successfully. And we'll go ahead now and load the video file we'll be using for this particular tutorial. So I have a video here named vid1.mp4 and is the video file we'll be using. And at the end of this tutorial too, I will share the code with you guys on my GitHub repository. So you can just go there and search for the name of the file there and you'll get access to it. Okay, so I will just go ahead and load in this video file and I'll explain each line of code for you guys. Alright guys, so with just these few lines of code, we are able to load in our video file. into OPCV. So I'll just explain them one after the other. So on the first line here, we are just creating a video capture object and we are giving it the path of our video we want to load. After that, since it's a video file, we'll be taking it in a loop. So I created a while loop here, while 1, which is the same as while true. Then we'll take our video from here. So I'm calling it image and this is equal to cat.read. The other ret variable here is also important. If there is video present, it will be 1, it's a boolean value. In absence of a video, it will just give you 0. And we'll use this to repeat the video over and over. After getting the video here, we'll go ahead and show it. So this line of code here, I'm just using it to show the video, cv2.imshow. Provide the frame, the name of the frame on which you want to show the video. And the video you want to show in this case is image, after which we have to wait and take each frame each second. So we provide 1 here. So let's test this up. We'll go ahead and run this. So you can see we have our video file here. And the guy here is easily pushing out. So this is working fine, and you can see the video we are out of frames. So the video is gone. So all we'll go ahead and do now is to find a way to be repeating this video continuously because it's very short. So for that we can say if not read, what we'll go ahead is to read back our video file once again. Then after reading it, we just have to write continue for it to repeat over and over and over again. So what I did here is that this ret gives you 1 when there is a video file and gives you 0 when there is no video file. So we are saying in absence of a video frame, we want to reload our video and then we'll continue. So if I should run this time around, our video will just be running over and over and over again. We will never be out of frame. It will repeat when it's done. And you can see it has just repeated. So with this done, we'll just go ahead now and resize our video into a fixed shape we'll be using. So I'll come down here and I'll say, okay, our image is equal to, we use the cv2.resize. Then we provide the image we want to resize and the size into which we want it to be. So I want it to be 1000, that's the width. And the height, I want the height to be 500. So we'll get a new shape now. Let's test this out. You can see now it's much smaller. And everything is just working as a charm. Okay, so now the next step here is to get our post detection module working. Now we've gotten our video frame, we've read it into OPCV. We have to also get the post detection on so that we can detect this post on the guy doing the presser. So for that, we have to create a post detector object from the post module we've imported at the top here. So I'll just write pd.not.pd is equal to our post detector. And in here, there are some parameters you can give, such as the tracking confidence. You can give it 70%, so 0.7. That is 0.70. And also the detection confidence, we can also put it as 70%. And that's it. And it's very easy now to detect posts with only 1 line of code. So what you will just do here is that you will say pp.find post. And if here you provide the image on which you want to find this post, and you will also have to specify whether you should draw the post or not. So I think by default it's drawing. So we can just put draw is equal to 1, even though it's still drawing by default, so that when we continue, we can kind of get rid of the drawing later part in the tutorial. So I'll run this. Boom, and just like a charm, you can see a post detection is working. So we get this out working out of the box, and we are getting all our posts being detected very well. So what we'll go ahead and do now is to extract the points. So let me close this up and also bring in our image. So we have to extract these 6 points. So we have 11, 13, 15, and we also have 12, 14, and 16. So these are the points we are going to extract. But now let's learn how to extract a single point. Let's say we want to extract point 14, for instance. So let's go ahead and do that. When you're able to extract point 14, we'll use the same way to extract the other different points. So to extract the points, we have another function in the CP zone, which is pd.findPosition. Then in here, we provide our image and also provide our, okay, it should drop. So if I say drop is equal to 1, bounding box with hands is also equal to false. So we'll put it as 0, and that's it. I can run this up, and can see now we have a bounding box on the person, but this returns us with our LM list and the bounding box if so we'll take our LM list, which is the landmark list in this case, or the landmark list on the body, and also we'll get our bounding box information. So we said our LM list and bounding box information, we are getting them from this particular function. So we'll go ahead and print our LM list, which is the most important thing. So what I mean by LM list is all these points on the human body, all the 32 points on the human body. So that's what I'm referring to, LM list, which is the landmark list in this case. So what I'll do is to run this app and pull this app, and you can see we have various lists here, which is containing some numbers. So these are the landmark lists, and we have to extract all this information from the video, and then we are able to target a point. Okay, so that's fine. Let's go ahead now and target our point 14. So to do that, we can just come down here and say, okay, our point equal to our landmark list at the index of 14, because we want to target 14. And as simple as this, you'll be able to get that particular point. So we'll print point 14, or we'll print our points, and we'll run this. So what we are doing now is to get only point 14. And you are seeing that now we are getting only one list for a single point. So for a single point, we are getting 4 different elements in this list. And with these 4, all we need is these 2 points. That's the second and the third points. So that's what we need, because these points are the center X and the center Y on the body. So now that we are getting that points, we can extract this point and maybe put a circle there to be sure whether we are getting the landmark for point 14. So what we will do is that we'll say our CX, which is our center X, and our center Y is equal to our points at index 2 and our point at index. So that should be index 1 and 2 here. That should be index 1 and 2. So let's put 2 here and change here to 1. And now we can use these points to draw a circle. So we can just receive a 2 dot circle. We put this circle on our image, and we give the points CX and CY. We also provide a radius of this circle. So let's make it 10 or even 12 so that we can see it well, and give it a color of red. Then the last thing is the thickness. We want it to be filled with that same color. So CSCY. Okay, that's fine. And now let's run this up to see what we'll get. So you can see at the point 14, we are getting a red circle there. That means we are accurately tracking these points on the human body. So if we pull up this image here, you can see point 14 is on the right hand, and that's exactly what we are getting, point 14 here. So that means we are now able to target a single point on the human body. So we just, based on this, we just go ahead and target all the points we need, And bear in mind, we need 3 points for each hand so that we can find the angle on the middle point, and based on that angle, we conclude whether or not the person is pushing up. So I'll close this up, and I'll also get rid of this for now. And for the bounding box, we'll also get rid of it. So we'll just specify here that draw is equal to 0. And let me test this before we continue. Okay, now we have no bounding box. So what we'll do now is to create a single function that will handle all the point extraction and drawing these points on the screen for us. So we just have to go to the top and define a single function that will take all the 6 points and extract the values for us. So for that, close this up, and I'll come to the top here, and I'll define the function. So I'll call this function, and I'll call this function angle, or let's make it angles. And this function takes in the 6 points, which is the 6 points we want on the human body. So if you see the human body, we want 0.16, 40, 12, 1.11, 13, and 15. So these are the 6 points we want to detect the push-up. So we'll give these points to our function. So we'll give it P1, P2, P1, P2, P3 up to P6. Okay, so we'll give it the points, and after giving it the point, we'll also give it the landmark. So we have to give it the landmark list first, so that based on this landmark list, it will find the points. So we'll give it LM list, and then followed by the points. What we can also do here is that we'll specify draw. So we'll give it draw points, and then we'll just indent it nicely. So before we find a point, we have to first check whether or not we have a landmark list. So maybe you've given a video file where it's not able to find any points or detect any posts. It's not going to draw anything. So we have to first check whether we are getting the landmark list before we go ahead and do point extraction and also drawing the points. So for that, what we can do, we can say if there is a landmark list, or better, we can check the length. Okay, let's just say if there is a landmark list, I prefer we do it like this. If the length of the landmark list is not equal to 0, so if the length of the landmark list is not equal to 0, that's where we'll go ahead and extract these points. So to extract the points, we already learned how it works. So let's say we want 0.1. We know 0.1 will be equal to our LM list. So that's the LM list at 0.1. I think we should change this variable now. Let's make it 0.1. And 0.1 will get the LM list at this particular point we've given to our function. Just do the same thing for all the 6 points so that we'll get the points. So 0.1 is that. We'll copy this and paste it for 6 times. Okay, that's 4 times the last one. I will change this to 0.2, 0.3, 4, 5, and 6. Then in here, we'll provide the same 0.2. Okay, so with this, we'll be able to extract the values in each particular point. But each point have about 4 values, as we have seen earlier. And in these 4 values, we only need the 2 in the middle, that's the second and the third point. So we'll go ahead and extract those second and the third point. What we'll do is I will say, okay, the first point will be our x1, and the second point will be our y1. And this is equal to our points. We are extracting the point from 0.1 to -1. That means you are taking the 2 in the middle. So if for instance our points is like this, let's say points is equal to a list that have 4 numbers. So let's say it has 3, my bad, 5, and 6. So we want the middle 2 here. So what we are doing is that we want to take from the first one. This one has index of 0. So this one has index of 1. So we are taking from 1 to -1. -1 here means we don't want the last one. So we want the first two. So we are just getting the first two for the center X and the center Y. So that's what we are doing. We can get rid of this, and we'll do this for all the 6 points so that we get the center X, center Y for all the 6 points. So as usual, I'll just copy and paste this some number of times, then we change it. So instead of X1 here, we'll make it S2, Y2, X3, Y3, and so on. Okay, so these are the points we have extracted. So up until now, we have gotten all the points for all the landmarks we have provided. So what we are doing is that now we are submitting all these landmark 1, 2, 3 here, and the other 3 here, which sum up to 6. And based on this landmark that we are giving here, we are extracting the points, the center S and the center Y. The final put is well commented, so you understand. The one I'll put on my GitHub, you understand. I've commented it so you can read through. So we are extracting those values, and now that we've gotten those values, we will have to draw on the body. Then we'll call this function and see how it appears. So to draw, we have to first see whether or not the user wants us to draw. So that's where we have provided this draw option. So what I would do here is that I will say if draw points is equal to true, we'll go ahead and draw our points. So we'll have to draw the first point, cv2.circle. We give it our image. Then here we'll give it our x1 and y1. Then we want the radius to be 10. And our color here, we want it to be 255, 0 and 255. The thickness, let's put it at 5. And for each point we've detected, we'll just draw 2 circles so that we make it a little bit beautiful, a little bit nice. So I'll just copy the same line and then we can just edit it up. For the second point here, what we'll do is that we'll change the color to another color so that we differentiate one point we are drawing to. So I'll change here to 255 and I'll change here to 0 and 0. Okay, so with this, we are drawing the circle on one point, and we have to draw this circle on all the 6 points. But now we can even call this function and provide the points so that we'll know what is going on before we continue drawing the points. So the name of this function is what? Angle. And we'll just put in our LM list because we have it here. We have the LM list here. And we'll provide the points. So the points are the points on the body. So we just put in those points. What I mean is these points. So points, let's say point 11, 13, 15, point 12, 14, and 16. So we are just going to put in these points. I will specify draw points here as 2, which is the same as 1. So we can run this to check the functionality of our function we are writing. And you can see this is working fantastic. So you can see we are getting 1 point being drawn on the shoulder. So what we have to do is to go ahead and draw the remaining points. Okay, so we'll go at the top here and draw the remaining points. Second circle, let's increase the radius. We have to increase it here. Let's make it this one 15. And let's run this again. And I see, okay, it looks nice. So we have to do this for all the 6 points we want. So for that, copy and paste is what we are going to use. We just copy this line of code, paste it, and instead of S1, S1, Y1, we do it X2, Y2, y2, that's x2. So let's run this, and this should be on another point. Okay, it's not. So what is happening? Let's check what is happening up. The second point we are given is 30, and over here we have 13. So I think it should be drawing. So 11, 13, 15. And we are giving it 12, 14, 16. So let's see, 12, 14, 16. Then we are drawing the circle x2, y2. Okay, so let's test this again. I don't know why okay, so for any reason it's not drawing. Let me check it out. So the reason why it's not drawing up here is that we are giving everything to point 1. So that means we are literally drawing on the same point. So you have to change here to the corresponding point. Point 3. Here should be point 4, 5, and point 6. So let's run this again and it should draw now. So you can see we are getting the second point also being drawn nicely. So what we'll do is to copy the same thing and do it for the rest of the points. Okay, so with this we are done for all the 6 points. So let's run this once again, and you can see now we are getting all the 6 points being drawn. So this is fantastic. We are now getting all the 6 points. So we have to continue now to find the angles and also join lines between these points. So let's first join the lines between these points, and up until now what we can also do here is to specify the drop to 0, so that we don't draw the post detection again. We only draw our points. So these are the points we'll be working with, and these are well detected. So let's go ahead and join these points with lines to make it look even more fancier. So we'll go ahead at the down here and draw the lines. And what we'll do here is that we'll say cv2.line. We'll give it our image, and then we want to draw the first line from x1 to y1, s1, y1 to the next point, which is x2, y2. We give it a color of red, and then we can put the thickness as 4 in this case. So let's run this and check whether the first line is being drawn. And you can see, so I've given it a color of yellow. I'll change this to red. After it looks nice. In my case, if you don't want it, you can just choose any color you want and just work with it. So we have to go ahead and join all these points. So for that, I'll just do all and we'll test it out. So I'll copy this some number of times and just paste it. Alright guys, so I've successfully drawn all the lines, and I'll run this to test it up now. So you can see we have all our lines joining nicely. So these are the points we have to work with. And now we are going to the step where we'll find the angles between the two halves. So we'll first find the angle for the first hand. We'll also find the angle for the second hand. Then based on this angle, we'll justify and draw on the screen and count our push-up. So for now, I'll close this up, and then we'll go to the next line and find our angles. So the final code is well commented, so we will know what we are doing on each line. But for this, we are just going through together. So after watching the video, you can download the code on my GitHub repository, and then you will see that one is a commented version. So now let's find the angle. We'll find the left angle and the right angle. So let's say our left hand angle is equal to math. We'll use the math here dot degrees. Then we'll find math dot ether. And inside here, we are going to find the distance between the points. So we'll find the distance between point y3 minus point y2 we also subtract the whole thing from math dot ether 2 again, and now we'll subtract point y1 minus y5 and this minus x4 minus x5. Okay, so this is for the left hand angle. This is how we can find it, and we'll do the same thing for the right hand angle too. So to do it for the right hand angle, we'll just copy this, paste it, and change the points. Alright guys, so this is how easy it is to find the angles. So now we have the right angle and the left angle. So this one should be right. So right hand angle and the left hand angle. So we can go ahead and print these angles here. So print the left hand angle and we also print the right hand angle. Then we can run this up to see the angles we will be getting. So we have an error, line 76, math.a10 decrease. Okay, so the problem is that we need a comma here and not subtraction. The same thing applies here. You need a comma here because it takes into values. Okay, so let's try this out once again. Okay, and this time you can see we are getting the angle value. So one is for the left and the next one here is for the right. But you can see these values are just number values we are getting continuously. So we have to convert these values to some ranges. So we'll check that okay, when the person is up, what is the left angle and what is the right angle, we'll write it down. And when the person is also down at this point, you can see we have negative and 28 for the right angle. So based on this angle, we'll map this angle from the range we have C here to 0 to 100. So from this range when it is up and this range when it is down, we'll map it to 0 from 0 to 100. So let's go ahead and do that, and that's where we are going to utilize the NumPy library. We can comment this out and I'll pull down here and I'll say still that my left hand angle is equal to me.interp, and inside of this function you have to give whatever I want to convert to that particular angle. So we want to convert the left hand angle and want to convert this from, I've checked for that list already, so we want to convert the left one from minus 30 to 180. So this is the range. When the person is down is minus 30, when it's up is 180. I want to convert these values to 100 and what, 0. So this is what we are typically doing. And we'll do the same thing for the right hand. So but before that, we can convert this to an integer right away so that we'll escape floating point values. I'll just copy the same thing here and paste it down. And instead of left angle, the note here should be right angle. Then we have to change the values for the right hand angle. So instead of minus 30, here we have 34 to 173. And we are changing it from 100 to 0 the same way. Okay, so what we'll do now is to print the same thing which we have here downwards, and we'll run this up again. and you will see we are getting them from 0 to 100. So let's see, if the person is down, that should be 100. That means for the right hand is not working that well. So what you have to go ahead and do now is to count when the person is down. So when it's at the, let's say from 0 to 100, when it's at the 50 points, we count that, we give it half. When it's down, we give it half, making 1. When it's up, so we'll count just like that. We'll not just count 1 when it's down, but some people can just do like they are going to press up, and they will stay on the way and they will not actually go down. So we'll be awarding 0.5, 0.5, so that we make it accurate. So to do that, we will start this, but we say our left and our right, and it's equal to left angle and our right angle. I just want a short form for left angle and right angle. So we are putting whatever values we are getting from this part into these two variables. And in order to count, we have to first bring up some variables that we use to count. So we can say one variable here should be counter. So we'll call it our counter, and straight away we initialize it to 0. We also do one for our direction, and we equate it to 0 as well. Since we are doing everything in a function, we can use these local variables in the function. So we have to find a way to use them. So we have to declare them as a global variables. So we just come here, we'll say, okay, our direction is a global variable and our counter is also a global variable. So just write global and then we write counter. We'll do the same for direction, global, and write direction. Okay, so that's fine. So now we have initialized them as a global variable. We'll just go ahead now and implement our counting algorithm. So when should we count? As I said earlier, we have to count when they are halfway through and when they are down. So we are awarding 0.5. So we have to check the angle. So we'll say if our left angle, so the left angle, that's for the left hand, is greater than or equal to 70%. Let's make it 70. And you have to check for the right hand. So, and the right hand is also greater than or equal to 70%. So if this condition is true, you have to also check the direction at which the person is going. Is it going up or down? So it will say if our direction is also equal to 0, which we know is 0, then what will go ahead, double equal sign. If our direction is also equal to 0, what will go ahead is to increment our counter. So our counter plus or equal to 0.5. And then after counting, you have to invert this direction to say our direction now is equal to 1. So we'll do the same thing for coming up. So we'll also say if our left is less than 70. So I think I can copy this same thing here and paste it here and just edit it. Okay, so instead of greater than, you are from down coming up, so you should be less than. Same here. So if it's less than 70 and the right is also less than 70, just check our direction whether it's 1, so not 0. So if our direction is also 1, so we have to give 0.5, that's half, and then we change our direction to 0. So this is our counting algorithm, and we'll count based on this. So let's go ahead now and print the counting value on the screen. So for that, we have to first design a rectangle where we will count on. So I will say C2 dot rectangle. The starting point is from 0, 0. The ending point, I'll put it 120 by 120. Okay. Then the color of this rectangle, let's make it blue. 25500. I will fill it by putting -1. Then we'll put the text of our counter on it. So cv2.put text. The text we want to put is string of integer of whatever our counter is. Then position where we want to put, you want to start from 4 to 70. Now the next thing is to specify the font size you want to use. So we use cv2.font. So we use the fat Hershey script simplest. Then you specify the font scale, we use 1.6. So all these parameters you can play with. The next one is the font color. So put this color to be red. And finally, we will specify the thickness of our score. So let's make it 7. And we'll run this app to check now. So we are having an error. Unsupported operand ls4 to bool. Okay, so I think there is an error somewhere here. There's an error here. Leave the comma here right away. And let's run this app again. Wow, and you can see anytime it goes up and down, we have it counting the number of times it's going up and down. And this is working nicely. When it stops at the top, you can see no false counting. So the counting algorithm is working nicely. Now we'll just continue and put the bars at the side for each hand, and also display at the top that we are doing a counting project. So now we are just coming to do something to beautify the interface we are working with. So for that, I'll just come down here, and the first thing I'll do here is to convert the interval we are using so that we can use it for our rectangle. So I'll do one for left and one for right. So I'll just say left val, and this left val is equal to our numpy mp.interp. So the interp function is used to convert from one rate to another, and here we are coming to convert our right value, and we are converting it from, that's 0 to 100, right? 0 to 100, and we'll send this to the length of our rectangle. So the rectangle will draw a bit from 400 to 200. And we'll do the same thing for the right hand too. So I'll just copy this, paste it here, and instead of left, I'll call this right file. And this is fine. Okay, so with this out of the way, we'll just go ahead and draw our first rectangle. So we'll do it for the right first. So we take cv2.rectangle, and here we'll give it our image. We want to put the rectangle on. Then we have to give it a starting point from 8 to 200, and a stopping point as well. So our stopping point should be from 50 to 400. So these values I've tested beforehand. We have to choose our color. Let's make this yellow. So, or let's make it green. Green in this case, yellow. Let's make it green. And the thickness, let's make it 5. That will be okay. We can change it anytime we want. And we have to draw 2 of these rectangles so that one will move in the other. One will be the bar that will be moving. So I'll just put it this way. And instead of the 200 here, we'll change it to the int value of whatever the right value is. So we can check this out. This one will make it -1 so that it will be filled. So if I see anytime it's going up and down, the rectangle is also filling it nicely. So we have to do one for the left hand too. And for the left hand, I will just copy the same thing. Come down and put it here, and then also change here to left val, and we have to change position so that it goes to the left side. So the position I've used is 952 and 200, 952 to 200, and the next position here should be 995 to 400. So it's the same thing here, 952. Here should be 995. So let's test that one up. So you can see this is working nicely for both hands. When it's up, it's up. When it's down, it's down. So that's nicely. It's not doing nothing, it's filling up. You can also put the text at the top. Now we know we are doing something for left and right hand. So we have a text here. We can copy the same thing and put one for the left and one for the right. I think I can minimize this a little bit. So let's tab this out and put one here for the left hand. So instead of this, we just going to create string value of as for the left L. And the same thing applies to the next one. We're going to do it R, but we have to change the position for the left one. So 562 to 195. Then for the right one, we have to do the same thing. So I'll paste it here. And this whole thing should be right. So the position is from 24 to 195. So let's test this out. So we have R, L. I think the font we are choosing is not that good looking. So we'll use the duplex, Hershey duplex. The same thing here. So let's check it out. Because it's looking nice. Okay. We have to change the color because it's not looking nice. So let's make it 255 and also 255. So this color is looking nice. The font is very big, so we can also play with the font size. Let's just make it 1. We are using 1.6, so let's make it 1. And test it out now. So I think it looks nice. Left, right. And the counting is also ongoing very well. Okay, so now we have done this. What we can also do is to change the color when it is full. Let's say when it's at the top, we'll change the color to red. Anytime it's at the top, we'll change the color to red. So for that, we can just use a simple if statement. Now, okay, if the left value is greater than this, then we have to change the color. So what I'll do is that I'll say, okay, if our left is greater than 70%, anytime our left is greater than 70%, what we will do is that I want to change the color of our rectangle. So we just bring our bar in here for the left, and we'll make the color red to signify danger. That means the person has done well, he's been able to push down. Do the same thing for the right. Instead of left here, you just have to change it to right. So for the right, we have to change the position. Here, it starts from 8. And here should be 50. So let's test this out now and see what I to change. So boom. Red. Anytime it's at the top, it turns to red. Wow, so this is working nicely. When it's paused, everything pauses. So this looks very nice. And I think we can also change here to blue. So let's make this place blue. So let's run this up. Okay, so this looks nice. This looks nice. The final thing we will do now is to put on the screen on top of it that, okay, this is an AI push-up counter, and then we are done. So this is working nice, guys. This is working very nice, and I think it's very accurate. All thanks to MediaPipe for doing the heavy lifting work for us. So I'll close this up and go down to our beginning code, the one in the while loop. And in here, we want to put right after the image what you see in the zone. So we say CP zone dot put text met. And what is the text we want to put? We want to put it on our image, and the text we want to put is /push up counter. Okay, so we specify the thickness and the position. So let's start with the position. This should start from 345, so it takes it as a list at 10. So I've checked all this before, and we'll now put in the thickness value. The thickness, you can put it to 2.5, and then we can give it a border value of 2. So with this being done, we can test it once more. So we are getting some errors. Let me check. Thickness is equal to 2.5. Oh, okay, so the thickness should be an integer value. We can't give it a floating point value. So let's limit it to 2. And also we can give scale rather to 2.5. So that will scale it up. Okay, so this is just working as a charm. And you can see the bars are moving just as the person is going up and down. So this way, guys, and I know you definitely like it. So do your best to comment what you think we can add to this, the improvement you think we can. In any way at all you think we can improve this, just put your comments in the comment section. But I know you definitely learned something if you have followed up to this point. Definitely learned something new. So this is where we'll bring this to an end. If you have any questions, I will take them in the comment section. I will answer you. The code and everything will be on my GitHub repository. The link will also be in the description for you guys to get access to it. Okay, so thanks for watching, and I'll see you guys in the next tutorial.